Hello everybody, this is Mr. Max here with another video. Today we're going to be talking about electron orbitals. So I have this video attached in our Google Classroom, so please pause my video right now to go watch this one. It's a good introduction on what we're going to be learning in the rest of this one. So please pause this, open that one up, and then come back. But how I'm going to start is first, how can we describe how an electron moves? So in this little video, we show that they're moving in perfect circles, and a lot of the times we draw them that way so that we can understand them very well. They are always moving, but they're not often in perfect circles like this. But the idea is that each circle is a different energy level. So the ones that are farther out have more energy and are moving more, which makes sense. If we have someone who's moving a lot, they have a lot of energy, they're going to be on the outermost circle, outermost orbital, I should call it. We have labeled each of our energy shells by letters. So if we say that, like in our video, we heard that if n is equal to 1, it's our first shell, n is equal to 2, it's our second, and so on all the way up. We label them K, L, M, N, P, and Q, just so that we have a common way to name them all. So if we're asking for our energy levels, that's what we're looking for. And then all of our electrons have suborbitals, which help give it the shape. So our electron shells are our energy levels, and our suborbitals, or subshells sometimes they're called, are the shape of them. And those are labeled with lowercase letters of S, P, D, and F. So let's talk more about our shells. Our shells each shell happens at a new energy level. So when our energy level goes up from our K shell to our L shell, it's the next energy level. A new period on the periodic table shows that we have a new energy level. So every time we go from our second row to our third row, or our third row to our fourth row, we're going into our next energy level. And also, each new electron will enter the lowest unoccupied shell. That's important to understand and remember. If we have an electron coming in, and maybe let's say we have the K shell fully filled, and we have 2 electrons in our L shell, 2 of our 8 electrons in our L shell, our electron will come in and fill our L shell before it'll fill our M. So our electrons want to be as close to our nucleus as they can be. They won't start filling the outside before the inside. It always is the lowest unoccupied shell. So we have a few shapes that I mentioned. Within each shell there are suborbitals, so each each suborbital has a different shape and energy. So S looks like a sphere, P kind of looks like a dumbbell, and then there are 3 different p orbitals, which is 1 for each dimension. So up here we have some good examples. We have a p with x being the x coordinate, pz with z being the z coordinate, and py with y being the y coordinate. So this is how we get our 3 dimensions. Our life is a 3-dimensional life. You might have even worked on some of this in math class. If you have even worked in 2 dimensions when we're maybe plotting a line or something, we do an XY plot. But that's the basic idea here. And then we also have d orbitals and f orbitals. So d orbitals get a little bit more confusing, where they will take up 4 different parts of one quadrant. So for example, here would be our z-axis and our x-axis with bubbles in each of our 4 quadrants for that dimension. So I have a good little illustration of this, and we're going to make it go a little bit quicker just so there's no sound. I'm going to be explaining this as it goes. So as we start, we're going to start by filling our smallest S shell, which is our 1s, and then we're going to add our 2s, and up here we have a little sign. We have our 2px coming in as a dumbbell, our 2py coming in as a dumbbell, and our 2pz coming in as a dumbbell. So real quickly, one thing to note is this is our axes. Each one of these arrows is a different dimension. So we have our z going up and down, our x coming this way, and our y going this way. But those are all, this is our next S, so then we'll go from our 2py to our 3s, and then a 3p, so we'll have another dumbbell situation that's much larger this time because we're getting bigger as we add more electrons, and we have our 3pz. Then we'll go to our 4s, which is an even bigger sphere I should say, it's a sphere. And then we start adding in our d's. So this is a 3dz squared. This is a 3d x squared y squared. A 3d xy. So they kind of look like balloons, especially if you tied 4 balloons together. That's kind of what our D shapes look like. But they fill a lot of different places in our electron. So that's what it would look like as an idea. Now the thing is, we don't often know, or I shouldn't say, we cannot say with full certainty exactly where our electron will be. We can only say that it will be somewhere in its orbital itself. So here's another way to look at orbitals. And when we start to think about filling in our orbitals and understanding where they will go in each energy level. So this chart has the different energy levels. We have an increasing energy on the left. So our first energy level is down here. Our second one is in this 2p, 2s. We have a 3s, 3p, and then a 4s, 4p, 3d energy level. Then our 5s, 4d, 5p energy level. So the idea is we would add an arrow for every electron that we add to our group. So we always add to the lowest unoccupied shell. So our first lowest unoccupied shell was our 1s, so we added 1 electron and then another, and then we'll move up to our 2s. So we don't go from 1s to 2s, we stay in our 1s because our first shell can have 2 electrons. Then we go up to our 2s and fill in both electrons. Then we go to our 2p and we will fill in all 3 electrons before coming back and filling in a second. So on each one of these lines, we can fill in 2 electrons. So we can get 2 electrons on each line, but we always fill the lowest unoccupied shell or an energy level. So it's easier to put an electron on this line, and this line before going all the way back and starting over. So we could put another electron here and another electron here. So since I have filled in 8 electrons, what element would this be for? If we look at our periodic table, we can find that number 8 would be carbon. So this is how our electron orbitals would look for carbon when we're filling in. And then how many valence electrons are there? So when we think about our valence electron definition, it's the amount of electrons in our outermost shell. So for us, it would be this 2p shell, and we just count 1, 2, 3, 4. So that's just a little information about ours. The other idea is you can see I'm using these half arrows. It's not a full arrow where they have a point on each side, but just on one, and I have alternated them. This one goes down, this one goes up. The reason we draw them this way when we're doing our orbitals is because each electron can have a different spin. They can be spinning clockwise or they can be spinning counterclockwise. So the idea is this accounts for a clockwise spin one way and a counterclockwise spin the other. So that's the way we do it. Now it is your turn. I want you guys to pause this video and draw a quick little chart in your notebooks and and fill in your 1s, 2s, 2p, 3p, 3s, 3p, 4s, 4p, 3d. You can stop at the 4p. We won't use anything more than that. And then I want you to do just like I did, and one at a time put in your electrons, but instead of for carbon, which we just did, for sodium. So for sodium, we can look at our periodic table and find that sodium is number 11. So we're going to have 11 electrons in here. So if I can find my present mode again, then the way it would work, our answer would be this. We would fill in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. So I hope that makes sense. If you guys have any questions, please let me know.